Viewers at home, I welcome you to my YouTube tutorial once again. Today we are going to physics. Don't forget, we have many videos on chemistry and mathematics. Just check the description button in order to get those videos. So today, what are you going to check under physics? We want to look at a quantity. Quantities. Quantities. What are quantities in physics? Before we can explain this better, we need to differentiate quantity from quality. We all know that quality cannot be measured, like love, like beautiful, and so on. But quantity, in other hands, can be measured. We can measure time, we can measure temperature, we can measure distance, we can measure the weight, we can measure the length, and so on. So we can now say that quantities are measurable parameters. And under these quantities, we have two things we need to consider. We have basic and fundamental quantities. Basic or fundamental quantities, and we also have a derived quantities. Derived quantities. These are the two types of quantities we want to look at: basic or fundamental quantities and derived quantities. What are basic quantities or fundamental quantities? Fundamental quantities are those quantities that we cannot move further to split, or they are the quantities that don't depend on other quantities. Fundamental quantities are those quantities who don't depend on other quantities. And what are the examples of those fundamental quantities? We have a time. Time is a quantity and it's a fundamental quantity. We have length. Length is a quantity and it's a basic quantity. We have a time, length, and mass. Mass is also fundamental quantity. We also have a amount of substance. We also have a temperature. Of course, we also have money, etc. These are examples of fundamental quantities. So time depends on no other quantity. Length also depends on no other quantities. Mass depends on no other quantities. So amount of substance, temperature, and money, if you continue like that. These are basic or fundamental quantities. But derived quantities, on the other hand, depends on other quantities. And these quantities are the fundamental quantities. We can easily say without fundamental quantities or basic quantities, we cannot get derived quantities. From the word derived, it means those quantities are extracted or are gotten from other quantities. So that is why we call it derived. They are derived from other quantities, and these quantities are fundamental quantities. And examples of these derived quantities are: we have area, we have volume, we have speed, we have velocity, we have acceleration, we have force, we have work or work done, we have power, and so on. These are some of the examples of derived quantities. Don't forget, we are under quantities, that is fundamental quantities and derived quantities. So these quantities, as you said, how are we going to recognize them? That this is time, this is length, this is mass, this is amount of substance, this is temperature, this is money, or this is area, this is volume, this is speed, this is velocity, this is acceleration, this is force, this is work, this is power, and so on. How are we going to recognize that these are really a specific quantity? That will lead us to what you call units. It will lead us to what you call units. We use units to recognize a particular quantity in physics or in any area. Let's take the unit of fundamental. fundamental units. Fundamental units. Fundamental units are the units of the fundamental quantities. They are the units that don't depend on other units. So they are the units of fundamental quantities which don't depend on other units. And examples of those units, for example, let's look at time. So we have quantity and their units. Number one, time. So we have time, we have length, we have mass, we have temperature, so let's take some of this, or let's add money. So the unit for time is seconds, that is x, second. We can measure time in seconds. We can also measure time in minutes. We can measure time in hour. We can measure it in day, week, month, year, and so on. So, meaning we can also measure it in minutes. We can measure it in hour. We can measure it in days. We can measure it in week. We can measure it in months. So, we also measure it in years. These are some of the units of time. So, anywhere we are referring to second, we are equally referring to time. For example, when I say 2 seconds, 2 seconds means I'm referring to the unit, the quantity of time. If I write 2 days, 2 days means I'm referring to time. If I write 4 weeks, it means I'm referring to time. So these are the units that tell us the particular quantity we are talking about, which is what? Which is time. So anywhere we find second, minute, hour, days, etc., we are equally representing them with what? With our time. What about length? Length can be measured in different forms as well. We can measure length in kilogram. We can measure length in centimeter. We can measure length in meter. We can measure length in centimeter. We can measure length in kilometer, in millimeter, etc. So these are some of the units for length. So anywhere we find meter, centimeter, kilometer, millimeter, etc., we are referring to what? Length. So this speaks about the quantity, which is length. What about mass? Mass can also be measured in kilogram. It can be measured in gram, etc. So we also have other way we can measure mass. So anywhere we find kilogram or gram, that means we are referring to this quantity, which is mass. What about temperature? Temperature can be measured in degrees Celsius. We can measure it in Kelvin, in degrees Celsius. We can also measure it in Fahrenheit. So these are some of the units for or to recognize temperature. What about money? As you know, that one is general. So money, when we see naira, when we see dollar, etc. So these are some of the ways we can recognize money. So we use unit to recognize a particular quantity. So these are the units for these quantities. And if you continue with others, like amount of substance is measured in mole, etc. Now, what about derived units? We also have derived units. Derived units. So these derived units, they depend on the fundamental units. Derived units depend on the fundamental unit. Without this fundamental unit, we cannot get derived unit. Just as without fundamental quantities, we cannot get what we call derived quantities. Area is meter square. How come about this? We know that area is length times breadth. So if this is measured, since it's talking about the distance of a particular end, so breadth is also measured the distance of a particular end. So we can say this is meter times meter, or centimeter times centimeter, or kilometer times kilometer, or millimeter times millimeter. Therefore, this is what? Meter square. You can see area is derived from this fundamental quantity of length. What about volume? Volume is length times breadth times height. So this is measured of length, length, length. So this will be meter times meter times meter equal to meter cube. So if you are using centimeter, it's going to be centimeter cube. If you are using kilometer, kilometer cube, millimeter, millimeter cube. We also have a velocity or speed. Speed is distance over time. So distance is what? Distance is also length. So which is meter all over time. Time is seconds. So we can also write this as meter per second or meter per 1. So this is the unit for speed. So anywhere we see meter per second, we are referring to the quantity, which is speed. And speed is a derived quantity. So you can see the way they are derived. So another one like velocity. Velocity is equal to displacement over time. So velocity and speed are equal. So they have the same unit. That is the similarity. But what differentiates speed and velocity is that velocity is a vector quantity and speed is a scalar quantity. So this displacement is also in meter over time, seconds, which can also be written as meter per second or meter per 1. So that is the unit for velocity. We also have for acceleration. So acceleration is velocity or change in velocity with respect to time. So the unit for velocity is meter over second times this particular time 1 over x, and is meter per second square or meter per second square. So this is the unit for acceleration. Don't forget, this can also be centimeter per hour square. This can also be kilometer per hour square or per days, anything. It depends on the type of unit that we selected, which will determine the actual value or actual unit for the derived quantities. So we also have others like force. Force is the distance, is mass times acceleration. Force is mass times acceleration. So if force is mass times acceleration, so mass is measured in kilogram, that's unit for mass, kilogram, then times acceleration. Acceleration is meter per second square, meter per second square. So this will give you kilogram meter per second square. So this is the unit for force, but force can also be measured in Newton. So you see that force is measured in kilogram meter per second, or we measure it in Newton. So force can be measured in this or this. We also have derived units for work. Work done is the product of the force and the distance. That is, work is done when we have force times the distance covered. So the unit for force is this, kilogram meter per second square. So times distance. Distance is meter. So when you multiply this and this will give us kilogram meter square all over second square, or you can also write it as kilogram kg m square by 2. So this is the unit for work. We also have for power. Or before we go to power, we also have another unit for work. Work is also measured in joules. So we can also measure work in joules. So work is equal to kilogram meter square per second square, or can also be in joule. Can also measure it in joules. Or if our force is Newton and distance is x, therefore our work can also be Newton second. That is force times distance. So these are some of the units to recognize work or work done. So we can also work for power. Power also has its own unit. Power is work done over time. So if work done has this unit, kilogram meter square over second times the time x, so this can be kilogram meter square all over s cube, which can also be written as kg m square x bar 3. So power can also be measured in another form. We can also say power is measured in, if work is joule and this is seconds, so we can say this is joule per second. So power can also be measured in joule per second. We can also measure power in watts. We can measure power in watts. So this is another unit to recognize power. So we can see that all these, they are derived from the fundamental quantities. Without these fundamental quantities, all these derived units cannot be gotten. So that is why we said derived quantities, they depend on the fundamental quantities. So the quantities we are talking of are basic quantities and the derived quantities. So after that, let's look at other quantities as well. We can also derive momentum. Momentum is also the product. Momentum is the product of mass times velocity. The product of mass and velocity, which is equal to mv. So if this is mv, then we have kilogram times velocity is given as, we have our velocity to be this or this, so which is meter by 2. So this will give you kg mx by 1. Do we see any similarity? Let's see if there's any similarity. No similarity yet. So let's look at another quantity as well. We can also derive for Young modulus. Young modulus. Young modulus. Young modulus is stress, which is tensile stress over tensile strain. So stress or tensile stress mathematically is given at force over area. Is given as force over area. And if tensile stress is force over area, then tensile strain is extension over original length. That is E over L. So we can now have our Young modulus at Young modulus as F over A divided by E all over L. So this will give us F over A then over E over L. So this is formula for Young modulus, and if you want to derive the unit for Young modulus, we can say F is measured in Newton then over area, which is meter square, divided by, this is also measured in meter, which is extension, distance, all over length, is also measured in distance m. So this cancel this, we are going to have Newton meter per meter square. So this is the unit for Young modulus. So among all these units, there is a particular unit that is common, which we can easily use to recognize any given quantity. So this unit or this method is referred to as SI unit. SI unit. SI unit. SI unit means Standard International Unit. Standard International Unit. That is the full meaning of SI unit. What is the function of this Standard International Unit? I have my name and I have my name in my certificate, but I have other names apart from my real name, but that real name is recognized all over the world. So people know me without my real name, but other names might be nickname or the name assigned to me by my friends or my relatives. But the standard one is the name which is used to recognize the actual particular unit. For example, like we said that length is measured in meter, in centimeter, in kilometer, etc. The recognized or the standard one all over the world known for length is meter. So anywhere we are working in physics, if we are given like 2 centimeter, before we can use this, we need to convert it to millimeter. So because millimeter is the recognized, meter is the recognized unit for this length. Also, the recognized unit for area or for time is seconds. So second is the recognized unit for time. So anywhere we have second, it is recognized. And if we are given a value, let's say it's in hours, like 2 hours, we need to convert these 2 hours back to seconds in order to recognize this time. So because seconds is the recognized or the standard unit given to time. Also for kilogram or for mass rather is kilogram. So for temperature is Kelvin. Also for other derived quantities like volume or area will be meter scale. For volume will also be meter cube. So for speed will be meter per second scale, and for velocity as well, it's also meter per second scale. And for other quantities like that, like density, which is mass over volume, is kilogram over meter cube or kilogram meter cube. So these are all what we can say under quantities. So in our next class, we are going to discuss more on these quantities by looking at the dimension of these quantities and solve some calculations under this topic. If you are new here, please help me to subscribe at the right button by clicking on the subscribe button. And if you subscribe already, I congratulate you and appreciate your effort. Help me to like and share to your friends. So I remain loyal. Next class we look at more videos on this. Thanks.